Well, here is just a very quick note on R squared and p-value. Now this is a very small data set, and this is part of the reason the p-value will be bigger, but it is to point out that R squared is telling you how well the data fit a straight line, but the p-value is telling you the probability that if these data are independent and should have a slope of 0, how likely is it that these data could have happened, right? So this particular slope could have happened. So we have a slope of 1.5, but we have very few data. And so when you run the linear regression on that, right, the slope 1.5, and down here I plotted it and so forth. The R squared is 0.96. So the R squared is fantastic. I mean, as you look at the data, I mean, it's just 3 points, but yeah, they pretty much fit a straight line very nicely, right? That's a very linear trend there. But the p-value is well over 0.05. Okay, so you can indeed have a p-value that would require you to fail to reject the null hypothesis. So I'm looking at these data, and wow, that looks like an upward trend, but my p-value is greater than 0.05. I would need to say, oh, I failed to reject the null hypothesis. The slope certainly could be 0, actually. And look at the size of that slope from the fit. It's 1.5. But no, statistically speaking, probabilistically, there's a 12% chance I could get data that look, pretty much like this extreme, this steep, or even steeper, and so that would say that even though I've got this great R squared value of 0.96, so that's saying 96% of the variation in my Y values is explained by that line right there. 96% of it. I mean, that's fantastic. If you have real life data and you have a 0.96 R squared, it doesn't get a lot better than that. And 99% or 100% is better than that, but you won't see that in practice real often. So that's very high, but my p-value, my statistical hypothesis test, unfortunately still fails, and it says, hey, I can't really claim that the slope is different than 0. Okay, so I can't really claim a dependence here between x and y, and so I need more data. Now if I had more data, sure, eventually, if it was this good, I would get a very small p-value. But it is very possible to have real live data with a very reasonable R squared, up around 50, 60, 70%, which is not bad, but then have a large p-value in which you would have to fail to reject the null hypothesis. So there we go. There's an example.